Good evening. Hi, Melissa. Can you hear me? Good evening, everybody. Happy Monday.
Happy Monday.
Is everybody tired from being out in the sunshine all weekend long? It wasn't that hot. It would have been a good night for excuse me, a good weekend for yard work.
Yeah, my yard needs it.
Hey, Kelly. So it's about 5:30. Hey, let me see. One, two, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we'll get started here in about another minute or two. We have a guest speaker tonight, so I'm gonna wait for a couple more people to trickle in. Ryan, I'm gonna send you a message really quickly in Slack. One of the students just pinged me. All right, looks like we almost have a full house here. So I'll go ahead and start it. It's a couple minutes after 5:30 now. Good evening, Jason. All right. And Melissa Smith. Hello. I know her mic goes in and out. I don't know what that's about. Okay. Melissa, can you hear me? Melissa, if you're having trouble with your microphone, you can text me in the chat or in Slack. Let me know if you're having any problems on your end. But in the meantime, I'll go ahead and do the Monday update. So first of all, once again, hello everyone and happy Monday. Just some quick announcements for tonight's class. We are currently in week 11 of module 5. Currently studying HTTP and APIs, RESTful APIs, JSON, and AJAX. And your instructor is Ryan Gaus, and your teaching assistant is Kelly Corey. We also want you to note that on Memorial Day, which is May the 31st, that classes are canceled. So make sure that you note that on your calendars. And we want you to enjoy your day off. Given the class cancellation, we'll also have our demo day on Tuesday, June the 1st. And tonight's guest speaker is Miss Melissa Schmitz, and she's an R&D engineer for emerging technologies, virtual reality tech lead, and a data scientist. Her presentation is entitled Introduction to AR for Web Developers. And we've posted a link to her presentation in Slack. I'll also go ahead and post it again for you in the chat. Her workshop is to provide an introduction to you to augmented reality for web developers. And in particular, she's going to discuss what AR is, why it's a hot new skill for web developers to learn, and to introduce you to some tools to get you started on your first project. She also wants you to know that in her free time, she participates in various tech-related events in the upstate New York community, such as Hack Upstate, Girls Who Code, and she's the leading XR strategist for Luma, for the Luma Projection Arts Festival, which typically brings in over 50,000 guests to visit upstate New York every fall. So that's the intro for Melissa Smith. And if you want to connect with her after the presentation is over with, I've also provided for you in Slack how to connect with her via LinkedIn. And Melissa, if you're ready, you can go ahead and start your presentation. I think she might be having some trouble on her end. I'm going to check Slack and see if she's left me any messages.
Hey everyone, Melissa, can you hear us? I think maybe you just might be on mute.
No, she's been trying to come off of mute for a little while now. Her microphone was coming in and out.
Looks like she just left. Maybe she'll try to rejoin in a minute here.
Oh, yeah. Okay, that's good. Yeah.
Might send her a quick note on Slack if you haven't already, Dana, just to see if there's anything we can do to help. Appreciate your patience, everyone.
No problem.
Hey, Melissa, just saw your note in Zoom. Yeah, unfortunately, we still can't hear her. Can anyone else hear her, Melissa?
No, I'm not able to hear her at all.
All right, thanks, Melissa. All right, that sounds good. Yeah, I was gonna say maybe just try changing maybe like your default audio input device, perhaps. That's the only thing I can think of.
Kelly, thank you for posting her LinkedIn information in Slack. Thanks.
All right, we'll give Melissa a minute here to try to reset. I appreciate everyone's patience while we get Melissa up and running here.
Yep, she just sent a note saying she's restarting now.
Thanks, Dan. while we're waiting for Melissa. Did anyone do anything fun over the weekends? Hopefully everyone enjoyed some of this beautiful weather we had.
Hey, Jahil. I'm just now realizing, first time we've seen you on camera. Well, the first time I've seen you on camera in a while. Welcome.
Yeah, my job, they're giving me more time right now. So
That's wonderful.
yeah.
Yeah, I know it's been a little bit difficult traveling and stuff, but welcome.
Yeah, they
Your
just
classmates are saying hello in the chat.
yeah, I'm catching up on my work, even though I have a lot of unturned assignments, but the 7-hour drive that we had today from
Wow.
here to Virginia, I was able to finish one of the assignments from, I think, module 4, which is still old, but I don't know. Cool.
Yeah, I think that's good that they're giving you a break. So, oh, hold on. All right, she's trying to reconnect to Zoom now, so hopefully she'll be able to log in this time.
Thanks, Dana. And yeah, if Melissa's unable to get up and running this time, let's hopefully she's able to. Melissa, can you hear us? Hopefully we can hear you.
Yeah, still trying to connect. No audio, no video just yet.
I don't know if this would help at all, Melissa, but you could dial into the Zoom call. I don't know if it's just a computer issue, but that is an option potentially if you want to try to give that a shot.
And Brandy, while we're waiting, I sent you a couple of messages in Slack last week after our tutoring session. So when you get a moment, can you just check the message and just respond to let me know that you've seen it?
Got it.
Okay, yeah. Okay. You know, at 5:40, she sent a note saying that Zoom was connecting. It doesn't look like she's having any success at this time, Jesse.
All right. Let's just see. Melissa, are you still in the meeting in the chat? You have ability to access that? Just wondering if there's anything else we can do. I see you're unmuted. I'm not sure why we can't hear you. I'm sorry, Melissa. I guess the last thing, just being cognizant of time, if you do want to try dialing in, Otherwise, what we can do, Melissa, is we can try to coordinate for another date and time. What do you think, Melissa?
Can you hear me now?
Oh, yeah, we can hear you.
That is so weird. I'm so sorry. I don't know why. My phone also decided to not have any service, so I borrowed my husband's phone. It's like the ultimate disaster. So
Oh, wow.
thank you for waiting for me.
Yeah.
I even
awesome.
tested the audio before because I wanted to have a video that had audio as part of my presentation, but I'm just going to skip that part so that nothing else goes wrong. But anyway, without further ado, I'll just share my screen and we can get started.
Thanks, Melissa.
Okay. So can you see my presentation screen?
Now, when you did the share, did you check the checkbox that also said to share audio?
I intentionally am not doing that this time because I don't want
okay.
anything else to get messed up with the audio potentially.
Okay.
So
All right.
we'll just
No
leave it.
problem.
And since everyone has the slides, they can look at the video later. It just won't be as impactful without without the sound, but it's okay. So as we said earlier, I'm talking about an introduction to AR for web developers. So, you know, what AR is, why it's a hot skill for you guys to potentially learn, and then introduce you guys to some tools to help you get started. So as you said, I'm Melissa Schmitz. I'm an emerging technologies engineer. And at Raymond, I work as an R&D engineer, where part of my job is also supporting a virtual reality product where we teach people how to drive forklifts in VR. So this is a bit of what that kind of looks like. And then also, as I mentioned in my free time, I'm pretty active in the local tech community in upstate New York, including Hack Upstate, as well as the Luma Projection Arts Festival. So there's not going to be sound on this, but I'll still play it anyway, so you can kind of see what I was trying to show. Basically, we did this opera that had live motion tracked faces and full body into VR, and people could also watch it on YouTube as like a screen recording. But this video is just kind of showing some of the tech that we use, like the tracking suits, and you see people have like a phone in front of their face because we're using a phone app to do some facial tracking. So all of that is live tracked in. We're using this technology ported into VR and then played live for live viewers, which is something that we did this past fall because we couldn't have a festival out in the open due to the pandemic. So this is something else that we came up with so we could still share some art with people in the community. And so if you're interested in learning more about that, then you can send me a message on LinkedIn or check out the Luma website. Just another example of some cool things that we're doing in the community. So other than that, I also wanted to mention that I did go to Lemoyne in Syracuse. So, you know, I also used to be from Syracuse, not anymore because I moved away for work, but I didn't study software engineering or computer science either. So I am also, you know, someone who had to forge my own path into tech in my own way as well, because it wasn't something that I directly studied. So I hope that I can be a useful resource to help you in your journey to a new career in tech through this program as well. And so now the most obvious question that we have here is, what is augmented reality? And to explain that, I'll go over a few different types of realities that we have. I can't see my slides.
I don't think we can see your slides. Can anyone see the slides? I'm not able to see them. And one of the students, I think he said he wasn't able to see them. Okay, so yeah, we're not able to see your slides. So can maybe you can stop the share and then restart it to see if we can see your slides. Okay.
Yeah, and if that doesn't work, Melissa, don't sweat it. Everyone does have the access to that link as well, so folks can still follow along.
Okay, can you see them now?
No, but what I can do is I can bring up your slides from my screen, and if you just tell me when to advance to the next one, I can do that for you.
Okay, yeah, maybe that'll be better because my
All right.
internet connection just seems to be not
Okay.
up to snuff today for some reason.
All right. Yeah, I'll go
Sorry about
ahead
that.
to the, yep, I'll go ahead to it. One moment, please. All right, and let's see. Now I just got to go back here to screen share. And where is it? Oh, there it is. Okay, can everyone see that? Okay, getting some nods. All right, so Melissa, are you able to see my screen share?
Yeah, I can see it.
All right, then let me go ahead and. Okay.
I'm not sure what slide I dropped off of, but.
Okay, so is this where you want to begin, or do you want me to go to the next slide?
So I guess we can just go to the slide where what is augmented reality? I think that's slide 6.
Okay.
I'm not sure where you guys left off, but that part wasn't like the major part of the presentation, so it's okay if we skip it.
All right. I'm trying to get past this slide. Hold on. Here we go. Okay. Oh, okay. I'm on the slide that says, what is augmented reality?
Okay.
Do you want me to go one more?
Yeah.
Okay. There we go.
Okay, we'll start here. So really the obvious question some people might be asking is, what is augmented reality? So first, I just want to explain some of the different types of realities that we have in this emerging field that we call spatial computing. So the easiest reality for people to understand is virtual reality, which is a fully immersive experience that transports you to another world entirely, all in the convenience of a VR headset, which could be something like Oculus Quest or an HTC Vive. And for all intents and purposes, you feel like you're actually there in the game. Augmented reality, on the other hand, is a completely opposite concept. So instead of transporting you into a virtual world, the virtual world is overlaid on top of the real world around you. So the most common example I'm sure you've probably heard about, if not played yourself, is Pokemon Go, where you can see Pokemon standing on the sidewalk in front of you or flying around the room as you try to catch them in the game. And this category also includes the various face filters that you can find on apps like Snapchat or Instagram. Then another term you might hear is mixed reality, which is similar to augmented reality, but a bit more complex in how the experiences are presented because there's an extra layer of reactivity. And so these experiences tend to be more enterprise at the moment because there's these added layers of technology that make it a bit more complex and expensive. But you can imagine something like a mechanic getting real-time information and feedback about his workflow while he's repairing a car, as an example. And so all of these types of spatial reality then fall under the umbrella term of extended reality, or XR. So if you hear XR being mentioned, it is referring collectively to VR, AR, and MR. You can go to the next slide, please. So now, when we're talking about augmented reality, even that term has a few different categories of experiences, which are all based on unique event triggers. So the first is marker-based, where a real-world object acts as a marker where you can place digital content on top of it. So machine learning is used to recognize an image, and then digital content is placed on top of that image, basically. So some popular examples might include something like an AR business card, where you can put like a video of your elevator pitch or other links to your social media or something like that. Or it could be something like a children's storybook where the characters can pop off the page. So the marker doesn't have to be 2D. It can be a 3D object like a can of soda, just so long as it's unique enough for it to be recognized by the camera. And then markerless AR doesn't require the virtual objects to be anchored to anything specific. So this could mean objects floating around you, like confetti falling from the sky after you complete an objective in a game. Or it could also mean like you can put objects like a couch in your living room and you just have to manually place it wherever you want to. On newer smartphones with LiDAR, such as the iPhone 12 Pro, infrared sensors are able to detect surfaces, which can help you place an object in the appropriate orientation, even if it doesn't require a specific placement. And then the last one is location-based AR experiences, which are triggered by a specific GPS location. And this could be something like an AR Maps app where arrows can show you the next step in the directions when you hit a certain point, like basically like when your map app right now tells you in 100 feet turn left, something like that. But this also doesn't even have to modify the visual world around you. It can also be a completely sound-based type of experience where you're walking on a city tour and there's a voiceover that's triggered as you walk past certain monuments. And I also showed another example from Pokemon Go here where the map is actually purely location-based AR as well. So that's another example. Next slide, please. And so now that we talked about generally what AR is, we can discuss some of the practical reasons why you might want to learn how to make AR experiences to help make you more marketable as an early career developer, since, you know, I'm trying to get jobs here. And then I'll also go over a bunch of examples of how you can see what this actually looks like in practice. So can you go to the next slide? So why are companies adopting augmented reality? Well, first of all, it's pretty innovative because almost no companies are using it. So it's new enough where if you do make an experience in AR or VR for that matter, you will actually be standing out as a company. So you will look technologically forward. And because of that, it's also in demand. So about half of retailers don't feel like they're prepared to start using this tech because they need help to do it. So having that skill also makes you more valuable as well. And once we already have that kind of in place, customers actually really do enjoy using AR experiences. So over 70% of consumers have said that they would shop more often if they used AR because it's a fun experience and it helps them understand the product more because they can try it out and things like that. And in cases where there are more customizable shopping experiences where you can say, like, change the colors of a sneaker that you want to buy from Nike, about 40% of respondents to this one survey said that they would be willing to pay extra if they had the option to customize the product using augmented reality. And as far as web developers come into play here, about a fifth of retailers are already using progressive web apps, which can easily integrate web AR experiences, and more than half of them are at least planning to implement it in the next 2 years. So there's a lot of opportunity to integrate that into your broader web development toolkit when you're looking for a job. Next slide, please. Now I'm just going to go over some examples. So one way that people do use AR in business is to do experiences where you can try before you buy. Next slide. So for here, the first use case I'm showing here is from IKEA, where you can place virtual furniture in your house to see what it looks like. Next slide. And then here's another example from Sephora, where you can do a try on of different lip colors or even full on makeup looks and then buy the product right in the app. Next slide. And then here we have another example with Barbie Parker, where you can shop for glasses in AR to see what they look like on your face. Next slide. You can tell this presentation was not meant for me to say next slide. Anyway, so, and then this one is one with sneakers, which I want to add that this type of experience actually is pretty complicated to get the tracking right. So doing this for full sets of clothing isn't as popular right now because it's a bit of a difficult problem because you have to drape clothing properly over people's bodies and handle all this like fabric physics. But people have already been finding some interesting solutions to this as we speak. So that should be coming in the near future as well. Next slide. And then the next category we have is augmented tourism. Next slide. So this first one is an example of a bus window that has an augmented screen on it for a city bus tour where it's showing information of the various monuments and things as they pass by. Next slide. And then this is an example of a user experience that you could have on either a phone app or a tablet, where you could do things like have information pop up about important monuments. Like in this case, the Big Ben, just it could pop up when you walk near it, or it can also show you kind of in the distance with these little markers, like where important things you might want to visit, like a bus stop or a taxi, are in front of you, as well as things like directions. Next slide. And then a bit of more enterprise type of experience would be something like remote assistant. Next slide. So here we just have an example of someone who's trying to repair, something with wires, and the woman who is on the video chat here has actually drawn some arrows to show her that you need to pull these wires back to see the component that you're looking to fix. And you can also have the board, the picture of the board on the other side of you, so you can look at it more closely. And this is obviously with an AR headset rather than a phone, so it's nice and hands-free. Next slide. But then there's also more simpler ones where it's just with a phone or a tablet. And as you can see, even just something as simple as being able to point to, like, yes, check that bolt specifically, saying that over just audio, it can be pretty difficult to communicate sometimes. So this actually really helps people get more specific with their remote assistance. Next slide. And then the next category that we have here is smart packaging. Next slide. So this one's pretty fun. Chiquita Bananas, they did a bunch of different campaigns, and they've actually been doing it for quite a while, so I couldn't find screenshots for all of them. But for example, they have some experiences where basically all of them, you scan the sticker on the banana, which most of us probably buy bananas and we think, this is useless, we don't need this sticker, and throw it away, obviously. So found it pretty interesting that something that most people forget about is actually turned into a cool experience, whether it's becoming a banana among a pile of bananas in the store, or they had an experience where the label kind of like looks like it lifts off and you can see more about how their farming practices are. And then they had all these different like fitness-based labels, which unfortunately I couldn't find a picture of, but apparently they allowed you to see bananas demonstrating all these different exercises that they're showing. So that's a pretty fun way to integrate AR in a unique way. Next slide. And then here's another example where this gin company has a bunch of different recipes that you can look through by clicking on the little tiles on the label. Next slide. And then this company had a tasting-based quiz. So once you taste this particular whiskey, it asks you questions about, what flavors you think you taste and what intensities they are. And at the end of the quiz, they give you a ranking of how good of a distiller you are. Next slide. And this one's a bit more simple, where, just laundry detergent. You can see videos, reviews, so it doesn't even have to be something super complex. It could just be something very practical and useful. And then lastly in this category, there was also this experience from Pizza Hut where people could slide on the different ingredients and like put it on half of the pizza and customize their pizza right at the table, which seems like a really fun experience. Next slide. And then the last category of examples I'm going to give you is just things that are for brand type virality and for fun. Next slide. So I think I might be behind a slide. Next slide. Onto the Burger King one. That one. Yeah, there we go. Okay, so Burger King did this ad campaign where basically if you found any McDonald's ad and you scanned it with your AR app, it would light the app up, or light the advertisement up in flames, and then a Burger King app would appear underneath it. And if you clicked the new Burger King ad that was covering that McDonald's ad, then you would get a free Whopper. So I thought that really went viral when I think this was only done in Brazil, because McDonald's was advertising significantly more than Burger King in Brazil. So it was a very clever way to use AR to get people talking about Burger King when, you know, these are two brands that are pretty ubiquitous that everyone knows about. So sometimes I don't even really feel like I noticed their commercials, but this generated a lot of buzz just using AR. Next slide. And then this one is a panel on a bus shelter. I think it was in the UK, done by Pepsi Max, where they created these like out of this world type of experiences that you would see through this window, where, you know, UFOs would show up, or like a big tentacle would just like take someone underground, or like meteors would come out of the sky, or some guy was like flying through the city on like a bunch of balloons, just like really crazy, weird type of animations that really got people's attention. And this one won a bunch of awards as well. Next slide. And then this one was at Starbucks Reserve, and I think is in Italy, where they have this really fancy wall, like this brass wall in the background, which has like all these maps and information about like the history of coffee and where Starbucks gets their coffee. So they have these app experiences where you can hover over different parts of it, and it'll show you kind of how the coffee trade has evolved through time, and, you know, places where Starbucks gets their coffee at different times of the year. Next slide. And then lastly, probably something that most of us have tried at one point if we use any type of social media, are face type of filters. So, you know, Starbucks has done various ones with pumpkin spice latte, the holiday drink cups, and some other fun experiences. Next slide. Okay, so I promise we're getting the slides that are a little bit longer than a few seconds now. So now that you kind of have an idea of, you know, what is possible with AR, we can talk about how you might get started in building your own AR apps as a web developer skill set. Next slide. So the most obvious platform for web developers to make an AR app, I would say, is on the web as an in-browser experience. So web AR experiences are actually an excellent response to what might be called the app problem, where your users either don't want to download a single purpose app, or you as a company don't want to lock yourself into a certain company's ecosystem on their app. So for this, I think it's a great place to start with AR.js, which is actually what I use to make my first AR app that I built actually at Hack Upstate 12. Next slide. So at Hack Upstate 12, my team made a boss battle MMO game where we projected our marker on the screen, and everyone at the hackathon could take out their phones and play the game through the browser, where all of us could see the same rubber duck, and we were all attacking it at the same time, which it did make different squeak noises for each different attack value, which was a detail that I was happy to add onto there. And so, you know, once everyone made all their attacks and you won the game, we could celebrate, you know, an end of a long night of coding. So that was a fun first app that I made. Next slide. So, you know, if you're at a point where you're pretty comfortable with using JavaScript and setting up your own web server and things like that, then this could be a great option. But if you don't think you're quite there yet, there are also some other great options you can start out with too. Next slide. And so the two biggest platforms for creating social mobile AR effects currently are Spark AR and Lens Studio. Spark AR is used to create effects for Instagram and Facebook, whereas Lens Studio is used for Snapchat. And as far as features go, these platforms are becoming more and more similar every day. So they both offer a variety of face, hand, body, and object tracking. Currently, Facebook and Instagram both have more users than Snapchat, but in 2020, there was a lot of growth in the use of Snapchat during quarantine. So it's hard to say which platform will be most relevant in the near future. But the good news is that both platforms are very similar, so that if you choose one and decide to switch later, it's a relatively easy transition. And as for me, I just happen to be most familiar with Spark AR. So I'll be using that more specifically as an example. Next slide. So, and we can skip this slide as well. So when you open up Spark AR Studio, this is what it looks like, where they have a bunch of templates that you can use to get started with whatever project you're interested in, whether it's a face filter, an animated poster, or a color filter, just seeing a few examples. Next slide. And then when you open a project for the first time, you'll see this interface. I apologize, I was going to use a laser pointer, so it might not be as helpful at this point, but here I opened up a project that I made for this, a disaster awareness type of effect, where it would help you kind of visualize what your environment would look like if you're in like a severe wildfire, like there was before in Australia and California, where the sky was red and there was like ash coming from the sky and things like that. So in this effect, we have embers kind of floating up from the ground and then ash kind of falling down from the sky. So that's the content that's kind of filled in this example. But on the upper left-hand panel, you have the scene panel, which contains all your device and object hierarchies. So your device, which is your smartphone, is at the top, and within that device you have its camera, and then the various properties derived from that camera, where you just place your objects based on, you know, what you're using to track them. And then below that, you have the assets panel, which contains images, 3D objects, and materials that you use to create your effect. And then you can edit these various properties in the right-hand panel, which you can see there's a bunch of sliders for like brightness, contrast, and things like that for the particular canvas that I put over the girl's face that makes it red. And then in the middle is the world view, where your assets are being placed, with a camera view that's right next to it, showing what the effect will look like on the phone. You can change the different phone screens if you want to see different sizes. And then just below that is the patch editor, which is a visual way to connect different events and properties together to create certain event triggers. Next slide. So here's a simple example of a patch. And this one makes a canvas visible or invisible on a screen tab. So if I had this one in my other patch, it would just basically turn the red on and off. So you can see how this is built, where you have a screen tab gesture that you feed into a counter. And then that counter goes up from 0 to 2. And when that counter equals exactly 0, then that canvas 0 object in yellow will be enabled as visible. So that's one very simple effect that takes 4 patches. So, you know, and some of them I feel like might not be super intuitive when you first start out. So it can take some time to get used to which ones you need. So tutorials can be very helpful here. Next slide. But of course, you can do a similar thing using JavaScript code, which is kind of the point that I wanted to get to here, was that you can use JavaScript to build various aspects of these experiences. You don't have to, but if you want to and you want to practice your JavaScript, or if you want to use a mix of the two, you definitely can. So you can imagine that when your interfaces get a bit more complicated, trying to hard code all of this could potentially be a bit more daunting. Next slide. So this is an example of what the patch editor looks like for this effect that I made, where basically it turns your face into a thinking face emoji, and then it allows you to change the background so you can contemplate whatever image is on there, whether it's art or maybe you're trying to make a snarky comment about something. And so here you can see why the patch editor is pretty useful, because it still does require you to understand programming logic in order to use it. But then if you need a custom effect that uses scripting, you can always add it in as a separate patch. And so that's why I think that this platform is good for practice. Next slide. And that's pretty much all the content that I wanted to cover today. So if you want to go to the next slide, actually, just leave it up. It just has a few effects that I made while we answer questions if you want. Yeah.
Nice.
So you can see the thinking face one. But those are just a few examples. So does anyone have any questions?
Yeah. So did you make the 3D models, or did you use like I don't know, like royalty-free, like models or whatever for your?
Yeah, good question. So for the thinking face emoji, I made my own because I just shoved a bunch of shapes together. So you know, the thinking face emoji shape is like an M&M basically, and then of course the eyes are like ovals and things like that. So so actually there's a slide after that that I saved for questions, which has links to some resources if you go to the next one. So so yeah, if you saw the dog one on the previous slide, I didn't make that dog. I'm not good enough to do that. I'm not a digital artist, but yeah, there are different sites that you can use models like CG Trainer, TurboSquid, Sketchfab, and Google Poly, to name a few. Obviously, you want to make sure that you either have whatever type of license you need to use it, if it's open source, or if you're trying to use it for like a paid app, then you'd obviously have to buy a commercial license. But yeah, you can find a bunch of different assets online just for fun, and use those to get started. As long as you're not using it for like commercial purposes, then it should be okay. So yeah, like I saw someone in the comments like, yeah, the rubber duck, I did not make that either. I found it for free on CG Trader or something.
So the AR plugin that you had before, like, does it work with WebSockets, or is it, do you have to use a separate API for that?
Yeah, so that was, it was a while ago, but I think it was separate. So like we made the app in its entirety, and then we added WebSockets so we can add multiple players to it. So without having WebSockets, you would just be playing like your own individual, I guess, instance of the game. And then WebSockets just allows you to create a server that will manage all the different requests at the same time, so that you can have multiple players. So yeah, that is something separate that you have to do. So it makes it a little bit more complicated, and I would recommend trying that for sure, because it's a super useful tool that with some of the people that I like to go to hackathons with who are very good at JavaScript, they tend to really like using WebSockets for various games. So it's definitely useful to learn, but if you don't know it yet, you can still make cool stuff with ARGS.
Okay, everyone. Melissa, thank you so much for a wonderful presentation. That was very intriguing. We're just about at the end of our time. Does anyone have any last questions for Melissa? No, going once, going twice. I don't see anything in the chat. Melissa,
Okay. Well, if anyone has any more questions, if anyone has more questions, feel free to send a message to me on LinkedIn or something. And again, I'm so sorry about the technical issues, because like, I don't know what happened, because it might have been an internet thing, I don't know, but thank you for bearing with me and looking at the presentation. So, all right, that's it for me.
All right, and don't forget, if you want to connect with Melissa, to connect with her, we put Kelly put the link for her LinkedIn in the chat, and we can put that in there for you again. And everyone has access to the slides, so feel free to review whenever you have time. And with that, Ryan, you can go ahead and get started on week 2 of module 5. Week 11 total. Wow, it's going by fast.
Great. Thank you, Dana.
You're welcome. Good night, everyone.
So I'll throw out there, this is the networking module. We're not actually going to talk about WebSockets in this module. We don't really have time. So if people are interested in that, feel free to reach out to me in Slack, and I'd be more than willing to pass you along some resources on things you look into that related to that. But we're just going to be talking about HTTP. Great. Okay. Let me share my screen here. Okay. Okay. So last week was quite a bit of information. We kind of started all the way back at TCP. We talked about how you can create network connections between computers, what's a TCP socket, some basic networking, IP addresses, ports, DNS, all those words. And then we slowly made our way through that, talked about HTTP as a protocol, talked about how you can make HTTP requests in lots of different places using different tools, talked about Postman, talked about curl, talked about Axios to make them in the browser. So this week, we're halfway through, and this week we're going to be not really adding anything more to like the tool set. We're going to talk about going deeper on HTTP, more details about it. So hopefully in module 6, which we're going to start next week after this week, you'll be prepared to get started with React and with Joey. So the first thing we're going to be talking about as part of this week is a bunch of information just on different request and response headers. So if you remember from last week, every HTTP request and response has headers in it. It's kind of just a part of the protocol. So we've kind of skipped over like different standard headers you might include. I've just said like you can include headers, and we've maybe used a few, but we haven't really talked about them at all yet. So today we're going to actually talk about some standards compliant headers that you'd use typically when talking with an HTTP server. And here's a list of what we're going to talk about. This is by no means a complete list of everything you can use, but these are probably, I think, some of the most important headers to have to wrap your head around. So we're going to talk about content type and accept. They kind of go together. Authorization, location, cookie and set cookie. They also kind of go together. User agent, the host header, and custom headers. So the first header we're going to talk about is content type. And content type describes the format of the data contained within the request body. So thus far, whenever we've sent requests that have a body, we've just kind of put plain text in there. We've just kind of put like a sentence, or maybe like just kind of like a made up protocol or something like that. But this week, we're going to start to actually talk about real sorts of formats of data you can put into bodies to when you make a request to a server. And this content type is a really important part of that. When you send data to a server, you have to tell it what kind of data you're sending. In practice, the reason why you have to do this is often servers can, an endpoint or a request can accept multiple kinds of data. And you need to tell the server how exactly it should decode that data. So a couple examples of what sort of value you put into this header. You put this thing called a mime type. We're going to talk about what that means in a second, but here are a couple examples of what they look like. Typically, it's 2 words. The first one kind of being like a higher level descriptor, and the second one being more of a lower level descriptor. So like text plain is the mime type for just plain text, like what you put in a text file or what you've been sending for the most part in requests so far. Let's say you wanted to put the contents of a PDF in a request, like you wanted to take the raw data inside of a PDF file and include that in a request. The mime type for that's application PDF. If you want to send a PNG image, it's image PNG. And the default sort of value, this default sort of mime type, if you don't specify a mime type, is this value called application octet stream. And the reason why that is because binary bytes contain 8 bits, octet, 8, oct, byte stream, octet stream. I don't know. I mean, I'm pretty sure that's why it's called that, but that's just kind of the default value. So there are a ton of these things. These are just 3. If you look up online mime type list, there are probably thousands of them. So what is a MIME type? Well, MIME type stands for multi-purpose internet mail extension. And the reason why it's called that is because they originally were used in email. That was kind of where they originated. So whenever you send an email attachment, somehow you have to tell the email program the kind of data that email attachment contains. So in the email protocol, or one of the email protocols, the way that they did that is they introduced this sort of notion of like a MIME type. So whenever you'd send data in an email, you'd say, here's just the raw binary data, and then here's the type of that data using one of these MIME types. And a MIME type, you can think of it very similarly as like a file extension. But a file extension, it's in the file name. And if you're just sending data that's not in a file, there's really no name associated with that data. So you can think of almost like a MIME type as a way of specifying the type of data similarly to a file extension, but for data that's being sent between two servers, not in like a file, just like being sent between two servers as raw data. So you'll see it in HTTP, you'll see it in like email, you'll see it in FTP, systems like that. They'll use MIME types, while just storing things on a file system will use a file extension. Now, similarly, we just talked about MIME types and using that for sending data to the server. There was a similar problem when you're receiving data from the server. The server data coming from the server could be plain text, it could be HTML, it could be an image. I mean, it could be a lot of different things. So we have a matching header we use that you specify in the request to tell the server what kind of data you'd like to receive. And that's the accept header. So the accept data header is pretty much the exact same thing as the content type header. It uses a MIME type, same default value as the content type header. Also, I don't think I mentioned this, but these both go in the request. So when you make a request to the server, you say with content type, this is the type of data I'm sending to you. And then you say with accept, this is the data I'd like to receive back from you. Does that make sense? Oh, can you show example? Yes, I'm going to show an example. Well, let me show an example now. I was going to show one at the end, but that's a good point. So here's an example. Let me go to module5.ml, our test server here. And I'm going to go into the dev tools, into that network pane where we are able to see all the requests being made. So, okay. Okay. This is what I want here. Yeah, so if you see here, the request headers. Through the CSS. And because I'm on the spot, my example isn't going to work. Let me see if I do a hard reload, if that changes it. Yeah, there we go. So, for example, the content type for CSS is text CSS, and ignore this part at the end. But you can see this request here is requesting a style sheet for what this page is. Styles.css contains some of the CSS to make this page look nice. And when it makes that request, it requests the content type of text CSS. And then it's accepting. Wait a second. Request headers. Yeah, I can't give you guys a good example of this. I got to wait until the very end when I have my pre-prepared example. Sorry. Trying to do this on the fly is making this a bit harder here. But what I can say is if you make a request to a server and specify the content type header, that's telling the server the data you have in your body, the kind of data you have in the body. And if really where that becomes important is if the server accepts multiple types of data and you specify the wrong content type, And the server doesn't understand how to decode the data in the body, and it gets really confused. And some servers, which are really strict, if you don't specify one at all, it will just kind of throw up its hands. Like it needs something. It needs to know what kind of data is in there. And if you don't tell it, it just is, it can't do anything. Oh, I do it. Okay. I do have an example. How about that? Okay. So I make this request here, this post request to example.com/foo here. I give it a content type of text plain, and I do an accept of text HTML. And the body, I'm just giving it plain text. So the content type here and the body, the data in the body, the kind of data in the body, it's plain text. So that lines up. So content type is for the data being sent as part of the request. And then the response data, you can see that's HTML. I asked for HTML, I'm getting back HTML. Now, it's also worth pointing out that with accept, that's like the best effort thing. Like you're telling the server, give me back HTML if you can. And if you can't, the server is going to try its best to do that, but you're telling it like what sort of data you'd prefer the server to send back. So it's no guarantee. Like if I made a request to maybe like Google.com, and I told it to give me back like a PDF, it's probably not going to do that because it doesn't really know how to do that. But if the server code is written so maybe it'll be able to give you back like plain text as well as HTML, and you give it an accept header of text plain, telling it to give me back plain text, and it can handle that case, it'll handle that case. Okay. What is good is we've got a good exercise on this in the assignment. So hopefully it'll make more sense when we get to that point. The second header I want to talk about is authorization. Authorization is a header you use. It's a standard header that you use to provide information to identify the requester, or identify you who's making the request. And why is this important? Well, on the web, there's a lot of information that typically you want to maybe only allow a specific subset of users to access, or maybe you want to link information to a specific user's web browser. Like, for example, you have a shopping cart, and you want to be able to keep track of that information associated with that user wherever they log in. Like they log in on one computer, and they have like a session set up, and they have a token associated with that session, and that token is included in every request, and it can now be used as a sort of identifier. So Dominique said subscriptions. Sort of. I would say that typically things, you're on the right track, but with a subscription, it's typically something that's being kept track of like on the back end, persistent for like a longer period of time. So something where like you have like a record on the server that's like saying you're subscribed to X, Y, and Z. Usually authorization is more about like what can you view. Permissions is like a really good example of authorization. So let's say maybe you have a web page that there's like a page that only maybe super users can access, or like people with extra permissions. In order to give them access to make that request, the server provider might require you to specify authorization information. Or basically identify that you are a person who can view that specific resource. So typically with the authorization header, there's two types of two fields you have to specify. What's called the scheme and the value. There's a bunch of different kinds of schemes. We're going to talk about two of them here. Very briefly basic, but more in-depth bearer. And those are I would say the two I use the most. There are definitely other ones out there though. So the way you would specify a specific scheme is you'd say like the authorization header, you'd set that, and then you'd put something like basic, and then the value that goes along with that scheme. So the data that you have to specify to say that like I am a user that can access this thing. Or for bearer, you do something similar where you put bearer, and then the value you have to specify to say I'm a user that can access this thing. Note that these are both uppercase, and typically the case for the scheme matters. So it's uppercase B basic, and then like the value, uppercase B bearer, and then the value. And there are definitely more different types of authorization schemes. These are the two we're going to talk about right now. So the basic authorization scheme provides a username and a password. So let's say you want to implement like a really simple way that you can allow someone to like enter a username and password and view a web page. One way you can do that is you can ask them to provide basic authentication credentials to view that page. So what you basically do is you take a username and password, and you put the username and then colon the password. You concatenate them together into a string that follows that format. And then you encode it in a special way, and then you include that in the authorization header. So effectively, in the authorization header, you're including your username and password in every request, and the server can decode it and look at it and see if it matches what it thinks it needs to match. And if it does match, then it will show the web page. If it doesn't match, it'll give you back some sort of 400 class error, like a 403 unauthorized or 403 forbidden or a 401 unauthorized or something, depending on exactly the error condition. But like that's sort of an example of like one way you could do authorization. You could take a username and password. You could include them in every request. The other way, the way that I think is a lot more common, is with what's called a token. And bearer is usually the authorization scheme you use when you're using a token. Although it's sometimes inconsistent, but for the most part, that's the case. So what is a token? So a token is a unique identifier pre-generated by the people who run the server. It's something that's secret that only you have, or the people who run the server might have a copy too, but like no one else has it. So if I have a token, Kelly won't have the same token I have. Kelly would have a completely different token. And effectively, if you only have that value and nobody else has it, anytime you specify that in a request, it sort of acts as a way that you can validate that you are who you say you are. Because if that token was only given to you and you didn't share that token, then if you're including that token in a request, then no one else could be making that request other than you. So it's got to be you. Typically, the way this sort of works is you somehow get into contact with the people who run the service. Maybe if it's a service provided by like your employer, you might there might be someone who runs the service and you have to talk to them. Or sometimes there's like a web form you can fill out. But somehow, basically, the people who run the service will generate you a token, and then we'll give it to you. That might be you take it off of a web dashboard and copy it in your clipboard and you put it on a file on your computer or something. Or it might be like it gets emailed to you, or there's a bunch of sort of different ways it can work. But at the end of the day, you need to get this token. And if you make a request to the server and don't include that token, the server is not going to know that you are who, it's not going to know that you are who you actually are. And therefore, it's not going to allow you to access the information you should be able to access. So a couple different places where this is important. As I said, authentication. So being able to access privileged information. Like let's say maybe you have write access to a page, and everyone else has read access. And the way you'd be able to update that page with like a post request with data inside of it is by providing an authentication header. Rate limiting is another thing. I should have mentioned that before. So often people who offer servers don't want you to make hundreds and thousands of requests to that server, because it's just a lot of extra load for them to deal with. And especially if like you're not paying them or anything like that, like every single time you make a request, their server has to handle that request. I mean, imagine like they've got like the nc-l command kind of running in the background on their server, receiving requests. And the more requests they get, the more load they have to handle. And it's like 1 or 2 requests isn't often that big of a deal. When we're talking about like a request a second, and you have like 50 people using the API all making a request a second, that's a serious amount of load. Like you have to think about that sort of thing. You have to plan how that system's going to work with that extra load. So rate limiting is a technique you can use where basically if you specify a token in your request, then you now know every single time someone with that token makes a request, it's a single person making that request. So you can sort of like keep a counter going on. And every single time someone makes a request, you can increment that counter. Another request comes in, you increment that counter. And it keeps going up and up and up and up. And then once it gets to a certain point, you can just kind of cut off access. And you can say like, oh, you can't access this API anymore. You've gone over the rate limit. And then typically what happens is like after some amount of time, that rate limit resets back to 0 again. So it sort of allows you to allot specific amounts of requests that certain people who use the API can make. And then permissions. That's the other kind of classic example, the whole read-write thing, where you can only, maybe you have access to write a page or read a page, and permissions, those kind of control that sort of functionality. And if you have a token, you have a certain amount of permissions associated with that token. So maybe you've got like a write token or like a read token, and that allows you to do different things to the server. Does the concept of token make sense? Cool. I'm seeing some yeses and thumbs ups. Okay. I'm gonna keep moving then. Oh, one last thing. You're gonna talk about tokens and security and all this way more in the security module. I'm doing a really high level overview, but yeah, they're gonna go way deeper into this later on. So as an example of what authorization looks like when successful, you specify something like, let's say my token was a value given to you by the token provider. You make a request with it, you get back a 200. You make a request with the bad token, you get back a 401. Or typically it's a 401. Sometimes it could be a 403 depending on certain situations, or it could just be a 400 level error. Because it's, remember, 400 means you messed up, there's a change you need to make in order to fix the problem. There's a change you got to make, you got to change your token. Okay, next up, location. Before we go too far into this, if you recall, we've talked about 200 class return status codes. We've talked about 400 class status codes. We've talked about 500 class status codes. So to review, 200 means everything worked great. 400 means it's your fault. 500 means it's the server's fault. We didn't talk about 300s. And some of you might have wondered, why is that? Well, it turns out there are 300 status codes. And the two most popular ones are what are called the 301 and the 302. And what they're used for is actually a pretty clever little thing. Imagine you've got a web page located at a specific location on the web somewhere, and you want to move where that web page is located. But the problem is you've given the link to where that web page exists to a bunch of people. So if you move it, now they're going to visit that page, and they're not going to be, like, they can't find the new location. I mean, sure, maybe you can put up like a page that says like, this page is moved, click this link to go to the new page, but like, that's kind of cumbersome. Like, it'd be really nice if they could just kind of like transparently be redirected to the new page. And that's what 300 class response status codes let you do. So if a server returns a 300 class status code, it basically allows the server to say, so we know you just asked for this page, but actually this page is moved and it's now at this new location instead. We're going to show a demo of this briefly here, but it effectively solves that, like, I want to move a web page problem. And there are two status codes, 301 and 302, that are important to know about. 301 is what's called a permanent redirect. That means the page is moved and it's going to stay at this new location. So in the future, if you want this page, go to this new location instead. Like, forget about this original location. 301 or 302, excuse me, is a temporary redirect. That means that the page we're currently at is going to be live again at some point in the future. So don't forget about it. Come back to this page in the future if you want to visit this page. But just for now, go to this other page. So like, one's a temporary one, 302, one's the permanent one, 301. And that's, in practice, you're not going to see 300 class response status codes used all the time. They're used like they're used occasionally, but it's not like as frequently used like 200s, 400s, and 500s. And also, just because you're probably wondering too, there are 100s, but those are way less used, like even way less used than 300. So we're not going to talk about them at all in this class. So you might be kind of figuring this out now, but if you're spending back a 300 class status code, you need to be able to somehow tell the client when you get that back from the server, you need to somehow be able to tell the client that 300, like where they need to redirect to. And that's what the location header will do. The location header is a standard place where when the server sends back a 300 class response code or status code, that's where the location that the client should now redirect to from then on is located. So an example here, if I make a request to example.com, the /first, for example, I might be looking for HTML. Maybe I'm trying to think there's a web page at example.com/first. But actually, no, there isn't anymore. It's been moved. It used to be there, but it's not anymore there. But it's actually at second. So what you'll get back is a URL. And then typically with web browsers, we'll do this automatically, which is cool. They'll say, oh, we got back a 301. OK, we'll just transparently now start another request, make it this new URL. And the data you get back for this is going to show up in the web page. And also when you do this, the URL is going to update. So like the URL is going to change to this value. But it's cool that the web browser handles this automatically. And it means that you can often move things on the server side and not really have to be all that concerned about the consequences if you properly set up these 301 redirects correctly. So why am I teaching you this? Like, when are you going to use this? You're going to end up encountering it at some point, and I'm telling you this now because it's super confusing if you don't know what's going on. But I'm hoping that now just exposing it to you is going to, when you encounter it for the first time, you'll be like, oh yeah, 301, that's a redirect thing. And remember to look for the location header. But you're probably not going to have to worry about like making requests that include it, or like when you get to the server modules, you're probably not going to need to worry about it. I just want to include it for completeness. It's an important header. Does that make sense? Cool, lots of yeses. That's good. Okay, next up, cookies. Who's heard of cookies on the web? Probably everyone. Have you ever wondered what a cookie actually is? So a cookie is actually very similar to a token, but it's kind of the older way of dealing with tokens, or older way of solving the problem tokens solve. So if you remember, a token is an identifier that only you have. It allows you to access information that you might that might be blocked from other users to access. It's something that gives you specific permission to access a page or perform a certain operation. A cookie does something kind of similar, or it can do something kind of similar. A cookie is information that is, it's a way you can store information that gets sent between requests. It's information that effectively gets saved on the local computer, the client computer, that whenever you make a request to the server, it's always included. So what that lets you do is from either the client end or the server end, add information to this sort of file. And then whenever you make a request to the server, it's included. So the server gets access to that data and can like the server could put an identifier, like a token sort of thing in there. And then the server could then, with that information, know, oh, you are this person, you have this user ID. Okay, you have access to do X, Y, and Z. Or maybe you can edit your profile, or you can add things to a shopping cart, or like you can, or more accurately, you can add things to your shopping cart and not someone else's shopping cart, like things like that. Cookies are a bit more flexible in tokens in that you can put whatever sort of information you want directly in the cookie. So with a token, it's an identifier. There's typically in a token, the contents of it doesn't really mean anything. It's just kind of random letters and numbers. It's just like pseudo-random. With cookies, it's more of like a kind of an object in JavaScript, where there's keys and values you can store. So you can store an arbitrary number of key value pairs. In practice, like you can't put an infinite amount of information in a cookie. They're kind of relatively small bits of information. but it does kind of allow you to sort of have like distributed data you can send to the client and have them store on their computer. So how does this work? Well, when you make a request to a server, there's a cookie that you can specify called set, or a header you can specify called set cookie. And you can specify a bunch of these key value parameters. So like key equals value, all space separated. So in this example, I'm setting this key foo to the value bar. And then from the server, I get back that in a cookie header. And when I get back in the cookie header, then gets stored into a file on the computer, kind of the file the browser manages. And then later on, so you can see how the content that was set in set cookie is the same thing you get back from the server. But then later on, when you make further requests, that data is included in the set cookie header until you clear it again. So this information is kind of like persistently always set in every request to that specific domain. So if I set like the foo cookie on module5.ml, every single time I make a request to any sort of URL on that domain, it's going to be included, and to like explicitly remove it by like not including it in one of the set cookie headers I send along. So you might be wondering, like, okay, these are two separate requests. Like, how is it somehow automatically sending this cookie information without me having to like manually tell it to send that information? Like, how is that happening? And the answer is browsers are really fancy. Browsers do all this behind the scenes. You in the browser, you set a cookie like in JavaScript. There's a way in JavaScript, like outside of requests, outside of the whole HTTP context, you say like, I'm going to create a cookie. And then from then on, every single time you make a request on that domain in JavaScript, it'll just include that set cookie header automatically for you. So cookies at like the HTTP level, like the headers, you never really have to set them, but they're important to know because if you're looking at like dev tools in Chrome and you see that cookie being set, like that is often important information like around providing like which permission related things like what user you are, user identification, things like that. Now, the other thing worth pointing out is the server can update the cookie too. So notice how I specify the set cookie here, header, and the server returns this cookie header in the response. But it is the same in this example, but it doesn't have to be. Like the server could add information here. So what's cool is that both the client and the server can update this. So it's a way that maybe like, let's say you were to log in, like you make a request to the server to log in, you give it a username and password. And the server returns back like a 200, and then it includes a cookie header with something like user ID equals, and then like the user ID, or like some sort of user identification information. And then from that point on, the browser is going to include that cookie. You never set it in JavaScript. It's just being set automatically by the server. And then later on, let's say you log out, the server could stop sending that information. So you make a request like the log out endpoint, like you go to like get log out or something. And then from that point on, the server receives maybe a cookie in the incoming request, but the response it gets back, it removes that in the cookie header. So the server can add things, it can remove things, it can completely update this however it wants. So it's often for that reason helpful to implement like logging in and logging out, but like tokens work for that too. Like you could make a request to an endpoint, you could say like log in, and the server could return a token, and you just store that token. Every single time you make a request, you include that token. So they're just kind of two different ways to accomplish the same thing. I'm mentioning both of them because tokens are probably what we're going to run into with more modern services, but cookies are still around, still used all the time, and you're going to encounter them. So it's worth knowing that both exist, but they both kind of solve a very similar problem. Does that make sense? And as for what clearing your cookies mean, I mean, you can probably guess it now from what I'm saying, but like you've got all these sorts of data, data is on your computer in your web browser. That's the value in these cookie and set cookie headers. Clearing your cookies basically just gets rid of all that data. So now when you make your next request, it doesn't have any data in that set cookie header being sent to the server. So why people often tell you to do that when you're debugging is, let's say maybe you're logged in, they want you to log out and like reset your state, like get back into a clean state with no sort of persistent cookie information. Like that's a way you can do that.
Hey, Ryan,
Yes.
how would you feel about like a 10-minute break before we jump into user agent?
Yeah. That's a good idea.
Cool.
Cool. Okay. In general, though, how's everybody doing with this? Doing well? Cookies to market to users, Mel says, yeah, definitely. That's one of many ways people get tracked on the web. You attach cookie to a request, and now every single time a request comes, you've got a cookie on there, you have an advertising ID on there. Ta-da, now everyone knows every single time you make a request. They can have that ID to correlate all those requests together. Yeah. And there's a bunch of security restrictions in web browsers to try to get around that and make it less of a problem. Are cookies used in social media platforms like Facebook? Yes, definitely. Definitely. Okay, let's take a break. Cookies store information the server and the client have once you request something. Yep, exactly. Okay. Let's do like maybe until 7:10. Does that work for folks? Okay, sweet. See you soon. Okay, it looks like everyone's nearly back here. I'm going to give maybe 30 more seconds and I'm going to get going. Okay. So next up, we're going to talk about the user agent header. Now this one's got a fun story associated with it, but the user agent header is a method that the server can use to identify what type of client sent a request. So for example, we've made requests now with a lot of different tools, like curl, Postman, the web browser, etc. If you were to take a look at the request each of those sends, you'd see they all send a user agent header, and each one sends a little bit different one. And this header allows the server to determine, like, did a curl call, is that what sent this? Did a web browser make this request? Was it Chrome? Was it Safari? Was it Internet Explorer? Was it Postman? It kind of allows the server to answer this question. Now, keep in mind, this is a request header and sort of opt-in. So you can definitely send like some bogus value, or you can remove it, or like it's not something you want to guarantee for the server to like have to always receive, but it's more useful as like a way of just getting analytics about what sort of browsers and what sort of users are using your system. However, that's kind of how it's used these days, but historically it's had a bit more of a use kind of where it was used to determine what sort of features were supported for a given browser. So this is what it looks like. It looks something kind of like this. Got all these like sections. You've got like, there's a lot of technology words in these things that are kind of obtuse and confusing. And you might kind of respond with like one of these sorts of questions, like what the heck's going on? Why does it look like this? Doesn't really make any sense. Like Windows NT 6.1, Mozilla 5.0, KHTML like Gecko. I mean, like you can think about as a computer trying to parse through this thing and understanding like what browser sent this. It's not an easy task. And one might wonder, how did it get to be in this state? Well, this is where the story comes in. So Mosaic was one of the first browsers. Its user agent string was NCSA Mosaic 2.0. That's pretty easy to parse, just that little bit. Later on, though, Mozilla came along, and its user agent was Mozilla 1.0. Mozilla was a more advanced browser. In particular, it supported these things called frames. So web servers checked in to see that the user agent contained the word Mozilla. And if it contained that word, it would send an HTML page with frames in it. If it didn't have that word in it, it wouldn't send the frames. So like the web page would adapt to the browser, would use the new technology if the new technology was available. And that's great. It was really great solution to that problem. But eventually Internet Explorer came along and it supported frames too, but they wanted to receive web pages that had the frames. So in order to do that, they added the word Mozilla to their user agent. And they also had the word compatible because it wasn't actually Mozilla. It wasn't actually like their browser. So they added the word compatible so that like you could determine if it was their browser or was the other one. But because web servers saw the word Mozilla in it, it would send the modern web page with the frames in it. So like it still solved the problem. But like now you can see how like, okay, this is starting to get a little bit confusing. Like they're kind of playing games in order to get the server to send the data they want. They're not really making something that's easy for people to understand. So this is already a little concerning, but then it gets even worse. Eventually, some servers started looking for the word gecko and served special pages in that case. KHTML, which was originally developed for a special Linux web browser, had the word like gecko. So now we've got compatible and like, meaning kind of the same thing, but different words for that thing. So they would get like the modern Gecko Firefox page. Then WebKit came along and they added KHTML like Gecko. So then like it gets like more and more confusing and obtuse. And that's how you end up with a thing like this, where like most of these phrases, like this phrase is basically in every single user agent. It means absolutely nothing because it used to mean something, but like now all these browsers are advanced enough for like trying to send special HTML for every browser is not something that's really done. What you will see is like Chrome 19.0. Like this is probably the version of Chrome making the request, but like there's also Safari here. But just through like tribal knowledge or like knowledge I know through working on the web, I'm looking at this and I'm thinking this is probably a Chrome user agent because just because it's what it looks like to me. And the point being, like, you should know these exist because, where is it here? Yeah. So these days, they're not really used very much for like their original purpose, like feature detection or like returning special HTML for specific browsers. But occasionally you run into systems that require a special user agent header or will maybe block specific headers. So they won't want you to make a request with like an old version of Internet Explorer, or more practically, like they might require you to send a specific user agent because they want to be able to identify like every single person who's making a request, not like more for like analytics reasons. So maybe if something goes wrong, they can see, oh, it was your app that made the issue, that caused the issue, and not this other application. And you're going to see it in every single request, so it's good to know what kind of it's about. But like, it's a mess, and if you find yourself getting into a position where you have to like parse a user agent or like read through it and understand like which web browser is this, you're probably headed down a bad path, like a path that's going to be filled with pain and tears. Okay, one more header. I know this has kind of been a day we've just been going all over the place with all these different headers, but we have some exercises here that are going to, I think, clear it up. Host header. This one is used all over the place. So the host header, it defines the original host name that the user requested when they visit a web page. So for example, if I visit example.com, I connect to example.com, and then I want to make a request to example.com. Traditionally, I'll include a header that includes this example.com domain name. Now you might wonder, why do you need this? Like, I'm specifying it here, like, isn't this just duplicate information? And you're sort of right. It kind of is, but there's an important clarification as to why it isn't. And the reason why it's important that it isn't is because when you make a request to a server, what's going on is it's doing that DNS lookup. It's taking this, it's converting this to an IP address, and the IP address is what it's actually connecting to. So when you've connected to that IP address, you've sort of lost the original context of what this domain was. So this header is a way you can basically tell the server, this is the domain I'm actually talking to, the domain I'm connecting to right now, and I want to communicate with. Now, you also might wonder, like, well, why is this important? Like, if you connect to an IP address, isn't that just going to be like the IP address that's associated with that domain name? Like, why is this a problem? The thing is, sometimes one web server will host multiple websites. In fact, if one web server couldn't host multiple websites, it would be pretty unprofitable to run web hosting businesses, because you'd have to spin up like a whole fresh server with its own IP address, or like have a network interface for every single customer. Like, it would get really complicated and hard. So what happens is the server receives this information and it says, oh, host example.com, and it looks through its list of hosts. Oh yeah, I've got an example.com. Okay. I'm going to do a get slash on that. Okay, great. So it's able to kind of, without this header, that sort of ability wouldn't even be possible. Yeah, that's the point I was trying to make here. So the host name never makes its way to the actual request, only the IP. There's no way for the server to figure out you actually visited example.com and not something else that had the same DNS lookup to that same IP address. So like if example.net also was the same IP address, from the server's end, it can't tell whether you went to example.net or example.com. It looks the exact same. So the host header fixes that. So it includes this return address information. And it's often, okay, exact same thing I just said. It's often used when you want a web server to handle traffic from multiple domain names. So like Hack Upstate, they might have a single server that hosts careersincode.org and hackupstate.org. Actually, I think this is hackupstate.com, not org. And that single web server can handle requests from both of those. And it's able to disambiguate them because of the host header. So that's pretty much all I have for today. Today it was just about headers. And these are the most important headers you're going to be using in HTTP, I would say. Just before we go to the exercises, I want to quickly go back up the list and just talk about which ones are request headers and response headers, because I think I left that out kind of while I was going through. So content type you include in the request, except you also include in the request. But except refers to the kind of data you get back in the response. So both of these are request headers. Authorization is also a request header. Location is a response header. So remember, that's what comes back with those 300 class return status codes. And the location header comes back and it tells you where the server or the client should redirect to. Cookie and set cookie. So the first one is a response header. The second one is a request header. User agent is a request header. So that's being specified by the client browser. Host is a request header. Oh, and there is one more thing I was going to talk about, custom headers. You might have seen, or maybe you haven't because I haven't talked about it yet, but you probably have seen headers that started with an uppercase X, like X dash something dash something dash something, or something like that. When you want to make a header that's custom, that's like something domain specific, the way you typically do it is you format with an uppercase X. So you start with an uppercase X dash, like X dash my custom header, like that. You don't usually just do this. And the reason why you format it like this is putting that X in front, that specific prefix that the HTTP specification has defined as like that's where custom headers go. If you just did it like this, and then later on in a future version of HTTP, they added in a header called my custom header, now you're kind of like overwriting that new header. And there's kind of a mixed meaning on what that header could mean. So you can get around that by putting this prefix on here. It means this is a custom header. It's domain specific. It's for the specific server. It's used in a specific function. It's not something special, or it is something special. Sorry. So this could be request or response header. Yeah. You probably aren't going to use custom headers all that much, but just I figured it was worth mentioning it since you might run into them. So that uppercase X dash means custom header. But that is pretty much all I wanted to talk about today. So I've got some exercises for you. The first one is about tokens. Second one talks about the host header. The third one talks about content type and accept. Because I think those are probably the three things you're going to run into the most and is most important to understand. I'm going to post this in Slack, and you can start taking a look at them. You can make these in whatever using whatever tool you'd like. Axios, curl, Postman. The last one's probably going to be easiest to do in Postman. But yeah, that's about it. In general, how are you all feeling about this? Cool. I'm seeing some thumbs up and some yeses. So let's see how the exercises go here.
Hey Ryan, I'm having trouble with exercise one.
Yeah,
If you wouldn't mind breaking down the wording, it's a bit intense. I feel like I don't have a token. I'm using
yeah,
Postman.
definitely. Let me share my screen here. Um, okay. So there's an endpoint that exists in the server, post tokens. The request is made to this endpoint, a new token is generated and returned in the response. So first of all, server's hostname is module5.ml and the port's 80. So that shouldn't be that should be pretty similar to what we've done in the past. So we know we've got to make an HTTP request. We've got to somehow get a token. Got the method here, got the path here. So if I open up Postman here, module5.ml, port 80. So, module5.ml, and it's port 80. So I don't have to put a port in. It's all automatically the ports used for HTTP. There's nothing special I need to do there. So the endpoint that exists is post/tokens. So I want the method of post. I want to use /tokens for my path. When a request is made to this endpoint, a new token is generated and returned in the response. Let me make this request to see what happens. Yeah, there we go. We got a token. So that's roughly what we need to do. Something kind of like that. Does that make sense?
It does. So exercise one, there's steps to it. Like there's steps because I was seeing like a post method and then get method, and I got confused.
Yeah, let me reformat this to make us a little bit easier here. Let's see. That look a little better? Yeah. So I think if broken up like this, it's going to be a little bit easier to understand, I suspect. So there's one request you've got to make to create a new token. Then the second request you need to make is to protected resource. It's got an authorization header with the bearer token in it. And if you include the token you generated, you should get back a success. If you include a token that is bad, you should get back some sort of 400 class error. Does that make sense?
Yes, I got it now.
Cool. Okay, so Susan said, I got this far, but now I don't know where to put it. I tried different versions of bearer and token, etc., but nothing. I'm using Postman. Okay, let's take a look at the token section here. Yeah. So take a look at one of these examples here. So the name of the header is authorization, and it's got two parts. It's got the scheme and the value. And typically with tokens, you want to use the scheme bearer, uppercase B bearer. In this case, my token is my token, that literal value. So if you add the authorization header and set it equal to bearer and then your token, you should be able to get a success returned from the server. Let me know if that works for you. Cool. Yeah, yeah. So Susan said confusing on Postman because there's an authorization tab. That's a really good point. Postman tries to give you a bunch of like extra ways you can like provide. Like I said, there are different types of schemes. These are all other weird schemes for different ways of doing things. Don't like. I would say at the point you're at now, ignore this. Just enter the header manually. That's going to be a lot easier. Yeah, Susan, you got it right. You want to use the headers area.
So I'm just curious, could people put in the chat if they're using Axios, Postman, or curl to do like exercise 1? I just would like to see how many people are using like which different source. I see a lot of Postman. Don't blame
Yeah,
you.
okay.
It's a real good resource. I was just curious. All right, I see an Axios in there. Cool. And you can't go wrong with any of those ways. They'll all accomplish the exercise. I was just curious. Looks like a lot of Postman. So thanks, everyone.
Hi, Ryan. I was a little confused about exercise 2 I wanted to ask. So it says to put in hack upstate and make sure you get back something that looks like the HTML of hack upstate. And the next part also says alter the host so it returns the HTML of hack upstate. Isn't that the same thing?
Let me reread it. Give me 1 second here. So what I'm saying there, and I'm reading it through, and I probably should have said this a bit clearer, is include the host header when you make a request to module5.ml and see what you get back. Set that to hack upstate or set that to creators and code.
Excuse me, Ryan. This is Latonia.
Yeah.
Hey, I'm on the third one, and I'm trying to figure out when it says to enter the set the value to the same as the image. I just put .jpg in the value. Am I doing something wrong? Because I'm getting a message that says status 413 request entity too large.
Oh,
What does that mean? Am I taking too long to input this?
No, I'll be honest. Noticed that this morning and I thought I fixed it, but I guess I didn't fix it.
Oh, okay.
Do this. Use port 5000 instead of 80.
Okay, thank you.
That'll probably fix it. Yeah, I'm gonna put a note of that about that in the exercises. If you're curious what's actually going on there, I don't know how many people actually care about that, but the way that I've got this hooked up is I've got a web server that receives requests and then proxies them, sends them off to my actual application server. So I've got like a server kind of in the middle that's processing requests before it goes to the final server. And that server, it does some validation, like it checks to make sure like request bodies aren't really large or there aren't any sort of problems with the request. And one of the things it does is if the request's over a certain size, the body's over a certain size, it just rejects it, because that's a common way that like you'll get denial of service attacks. You're going to talk about that in the security module, but basically like if someone sends a bunch of requests to a server that all contain a ton of data, server's going to be spending a ton of time processing all that data and won't be able to understand real requests when they come in. So yeah, use 5000, you can get around that thing and just talk to my server directly.
Hey, Ryan, question from the chat.
Yeah.
Latonia asked if she should try making the image smaller. She says that didn't work. Try 5000.
You could. You got the same error you got before, the 413 request too large?
No, the second one just said bad request. I'm sending them to you in the Pasted Code channel now.
Okay.
I could be doing something else wrong. Yeah, let me I'll send these hopefully. Just give me 1 second, okay?
Yep.
Actually,
Susan,
oh, good. You saw it, so go
I
ahead.
saw it. Okay. Yeah. So Susan asked, "Do I need to clear the area, my area in Postman? I still see my token from exercise 1." Yeah. Clear it out. And make a new request for each exercise. I think in practice it's not going to matter, but just as a academically, that should be the way you do it, so you don't have any side effects between these exercises.
There's also a different question from Carolyn in the chat. She said, "Are we supposed to receive a promise pending for the first step in exercise 1?"
Promise pending. Yeah. Well, that's what you're going to get. I'm assuming you're talking about Axios. That's what you're going to get if you run axios.get or run that request in the console. That's what's going to be returned by Axios. But remember, from the office hours, you've got to unwrap that promise. You've got to get the value inside of it to actually see the response status or response body.
So I have to do those extra steps before I go to the next step.
Yeah, so you have to make your request.
Oh.
You've got to do the promise.then. You've got to log it out. You got to take a look at it.
So I picked the harder one that I shouldn't have picked.
Harder is relative. I mean,
Okay.
I guess harder in more keystrokes typed, but like you pick the one that's more relevant to like actually writing code for this later on.
Yeah. Oh, okay. So I do need to do all that stuff we did in the other exercises in the homework.
You do, but it's you just need to basically just it returns a promise, get the value inside of it with .then, log it out, and that's about it. Or you can take a look in the network too.
Status or the data? What is it we want to get?
You're doing the first exercise?
Yes, I'm still stuck on that.
No problem. So if you're getting the token, the token is going to be in the body, the response body. I would say just log out the whole response, and you can take a look at the status and the data in there too.
So just log out console log response,
Yep, I'd say
just
do that.
response, and then see and take it from there. All right,
Yep.
thank you.
Ah, so Latonia, your problem is you didn't set your content type right. So remember. Oh, so what did you say?
I said no, as like I didn't.
You didn't. So remember, the content type, the value of it is one of these mime type things.
Oh, and I just put in like it's literally a JPEG.
Yeah. So
Okay.
you should look up online, like what is the mime type for a JPEG file or something.
Okay. Thank you. I had just made it smaller and cleaned everything out. I'll try that. Thank you.
There might still be an actual problem going on here too, but that's definitely something you gotta fix.
Okay. I only asked that because I know image files can be really big, and so I didn't know if that was relevant or not, but it might have ended up being a silly question. But
It's definitely a thing that can happen. Like this is the sort of problem you often run into when you implement like image uploading functionality. So yeah.
Oh, quick note. I just double checked, and if you add port 5000 to exercise 3, it does work. I got back an image successfully received, thanks. But you have to have the 5000 in there or else it's gonna fail.
Yeah. I really should have upped that Nginx body limit. I'm kicking myself now. Kyle, would you be able to put in the pasted code channel an example of what your header looks like? Kyle, look very closely as the tab you're entering your information on. Yeah, Postman has a bit of a misleading interface, especially for beginners.
Okay, so I want to be under the authorization tab.
No, you have the params tab selected right now.
Okay. Oh, headers. Okay. Thank you. That was just the default one. All right.
And notice, this is actually maybe an educational thing. Notice how it puts what you put in the params tab, it actually puts those as query parameters in the URL. Like you see how it says question mark authorization equals, like that's what that's about. That's how you can enter query parameters. So Susan says, I got 1 and 3 done, but I don't understand number 2. So the number 2 is trying to talk about the, oh, Shaw, yeah, that's the correct response. But number 2, the idea of that is, pretend that module5.ml, hackupstate.com, and careersandcode.org are all hosted on the same server. And I've done the finagling on the back end so that you can think of it like that's how it works. They're all hosted on the same server. So if you make a request to module5.ml with the host header of module5.ml, you're going to get back the module5.ml homepage, that index.html page. It says like, this is the module 5 server, that page. But if you make a request to module5.ml with hackupstate.org or hackupstate.com or careersandcode.org, you're going to get data that looks like those pages because you're talking to the same server at the end of the day. That host header is the only thing it can tell, the only thing it can use to figure out where you're requesting, what you type into the domain, like what domain you're requesting data for. So what I said for exercise 2 is let's pretend that the module5.ml server also hosts the hackupstate.com and careersandcode.org sites. So make a GET request to the hackupstate.com server as you normally would in a browser. Make a request to the hackupstate.com server as you normally would. Ensure you get back what's expected. A bunch of HTML that looks vaguely like the Careers and Code. That should say hackupstate site. Oh yeah. Like the hackupstate site. So that's step 1. Make a request to hackupstate.com. Take a look at what you get back. Make sure it looks like what you'd expect. A bunch of HTML. So then the idea is make a request to module5.ml, but specify a host header of hackupdate.com, and then see what you get back. It should match. I mean, it's hosted on the same server. Well, in this let's pretend scenario.
Oh, okay. The way I read it was make a request at hackupstate and then make another request at hackupstate. I don't realize you're switching it to make the request.
Yeah, let me rephrase
that's worded weird to me, but I think I get it now.
Okay.
Thank you. I think I'll try.
Okay.
Yeah.
Okay, I think I reworded that to make it a little easier to understand. Kyle said, I got Axios to work, but I didn't realize I had to have the browser on the module5.ml page when I opened the console. Yes, we're actually going to talk about in a couple days why that is. But for now, if you're making any Axios requests to anything on module5.ml, go to that page before you do it. Yeah. Well, we're at 8 o'clock here. Does anybody else have any questions they'd like to ask me right now? Or you think it's time for us to wrap it up? Okay. I think then that's probably all it's going to be then for today. I made an assignment on Google Classroom while you folks were starting on this, so I'll post that in Slack. In addition, there's the 30-second feedback I'd suggest you fill out too. Either Kelly or I will post that in Slack. But yeah, other than that, have a good evening and see you tomorrow. Bye.